Welcome. I am Jackie Jacob. I am the coordinator for the Small and Backyard Flocks Community of Practice on e-extension, and I help organize these monthly webinars. Please, I will put in the Facebook page and where to find all the other webinars. We have over 50 webinars that have been recorded that you can view online. But today's webinar is on ventilation and insulation for backyard poultry housing by Bob Schultheis. He's with Webster County Extension Center in Marshfield, Missouri since 1980. He works a 23-county region of southwest and west central Missouri, helping people solve problems on a variety of agricultural engineering, environmental quality, information technology, general agriculture, and rural community development concerns. So hopefully he will give us some insights into ventilation and insulation for our backyard poultry. I will be on mute, but monitoring the chat box and the Q&A. If you have a question at any time, please feel free to type it in either location. If the question is directly related to what he's talking about at that time, I will interrupt him to get the question asked. Otherwise, I'll wait till he's finished his webinar to ask more questions. But feel free to enter your question at any time. It's all yours, Bob.
Okay, thank you, Jackie. Yeah, just kind of start out on this, the ventilation and insulation for backyard poultry housing, maybe where we got in touch to start with was we put together a project about 7 years ago, a workshop in Springfield, Missouri, and we had a really good turnout. We had a lot of interest at that time related to backyard poultry housing because of an ordinance that the city was going to have to allow poultry inside the city limits of a metropolitan area. And so I'll make reference to that on a couple of slides here as we go through. But overall, the message we want to give to folks when they do this type of thing, and there it goes. The idea is to keep from ventilation and insulation is to keep your poultry healthy, and most poultry can handle cold very well if they're kept dry. Whenever we get cool and humid conditions and inside the poultry housing, then it can create health problems for the birds. And so we're trying to keep them dry as best we can. We want to keep them clean in a draft-free environment, and this can be a year-round. We want it to be a year-round situation, but where I live here in the southern part of Missouri, it can get extremely hot during the summertime, and so it's useful to know that chickens can't sweat, so they start to pant when it gets around 95 degrees, and that can create problems for the birds if they're in an enclosed building and we aren't providing proper ventilation. One of the things that always comes up is how small of a building can I put these birds in, or I've got this little bitty area and I want to put 25 or 30 birds in it. Will that work? And I'll show you a little bit later a table that gives the space requirements for the different types of poultry, and it'll mention something about minimum space area, but you can always get in trouble when you do just minimum. So we want to look at providing a little larger space than minimum if we can. It'll help lessen odor and fly problems and disease issues that carry over. For the most part, we're going to be dealing on these small houses, hen houses and coops with natural ventilation. If we were into some of the larger really big facilities like we have in Southwest Missouri here, with many thousands of birds in the building, all of those would be mechanical ventilation. But for these small houses, natural ventilation is what we're going to talk about today. And one management aspect that goes with that is dealing with the litter, and how we manage the litter in the building can also help reduce ventilation issues that we might have. These were the typical regulations in the Springfield area that they came up with when they were talking about putting an ordinance in. And I don't know what it might be in your community, but if you're in town and you're thinking about doing this, check to see if there's any ordinances that would apply. Usually it's going to involve no roosters, and it's going to have to be located to where people can't really see it well from the street. If you're out in the country, this really isn't a big deal, but setback requirements in town, usually it's going to be 3 feet from the property line, at least 25 feet from other residences, businesses, schools, and so forth, and managed in a way that odors would not be detectable at the property line. And so the goal is to keep that housing clean and dry, odor-free, neat and sanitary at all times. Another aspect is check with your neighbors first. If you're thinking of building this and you're in town, show them what you plan to build. Make it look attractive or inconspicuous. And what we find is that most people, like that picture in the upper right-hand corner, that is not going to be considered acceptable for most in-town type uses. So something more in the lower right might be what some people have in mind. And different ways that they can do this. They can either build new, they can acquire or refurbish something, pick things up out of dumpsters, get some torn down building somewhere, and they will repurpose it into a bird sanctuary of some sort. They can buy kits and assemble these, or they can buy a finish unit. And we actually looked at the economics of doing this too, where they go out and buy a poultry house for maybe 6 or 8 birds, and what it comes out to is about double the price of a dozen eggs compared to just buying them in the grocery store. So factor that in if you're thinking that you're going to raise them cheaper than you can buy them in the grocery store. You're probably not. And then if there are ordinances, what kind of enforcement rules go with that? But those are some of the factors that we look at for in-town type housing. Might be useful to talk a little about, as I make mention of the different types of houses. Brooders are where you typically are going to raise the little chicks up into larger birds. A hen house can have either runs inside, runs outside, or it may not have any runs at all. And this is basically an exercise area outside, and that would be for birds only. It's not big enough to put a human inside. Chicken tractors, some people are interested in those. These are bottomless movable pens that you can move around the yard or the field and let animals fertilize the yard, as well as pick up bugs and eat those. And a chicken coop, for our definitions here, would be large enough that a human could enter and share space with the birds while they're doing chores. From a ventilation point of view, you could see from those earlier pictures that those are very well ventilated, lots of open space, and they're very good at supplying fresh air, which is essential to life of the animals. The other goal of effective ventilation is to remove any excess heat, any excess moisture or dust, and reduce the odors in the building. It also helps dilute any airborne disease organisms and bring them down to tolerable limits that the animals could handle. In the lower picture, those diagrams in the lower are kind of an artist's conception of how you might manage ventilation in the summertime and in the winter. In the summertime, we're trying to bring in cool air from down low and exhaust it out up high through the ceiling and maybe through the attic, depending on the size of the building. In the wintertime, it's essentially the reverse. We're trying to bring in cooler air from above and warm it before it gets to the animals that are down lower. And I put some references in here too, if you're wanting more information on these, where you can go to gather more details on that. The housing location, where you put the housing for the birds, largely depends on wind direction. In the northern states, we may have to deal with a lot of cold northern winds. And I'll show you a little bit too where some of these winds are here in a little bit. In the south, we usually are trying to take advantage of prevailing winds. And these may be southerly breezes that we're trying to get rid of a lot of heat in the building. If you've never heard of the term a windrose, what that is, the picture below is an example of what a windrose is, and it varies throughout the year for different locations, and we'll show you the strength of the wind, where it's coming from, and where it's headed to. And this one's color coded, so you can see that for this location, the predominant wind is coming from the south-southeast. Almost the majority of the wind is coming from that direction, and then other parts of the month it would be coming from those other areas that you see in smaller rose areas on there. I'll switch over to a map that shows the whole country here. This is January wind currents, and you'll see kind of a spider web coming out from a central point at these different locations around the country. What those, the longer the web is on any particular side, so if you look, for example, at Casper, Wyoming, it shows a very large percentage of the January wind currents are coming from the southwest and going to the northeast. If I zoom in a little bit and look at Kansas City, for example, you'll notice that a large percentage comes from the northwest and also from the south-southwest. And so if you think about where you locate your building, you'd want to put it in a place that will offer some protection from those the cold northerly wind, but also provide some breezes. And as we look at the July wind currents, breezes coming from that direction, we want to take advantage of those winds. So if we go back to Casper, Wyoming, as an example, you'll notice that it's pretty uniform. The breezes can come from every which direction, north, south, east, or west, pretty uniformly throughout the month of July. And I'll zoom in again on Kansas City, and largely most of the breezes then are going to be coming from the southerly direction in Kansas City. And this will vary again all over the country. I'll show you a tool that you can use a little bit later. It's called our Ag Site Assessment Tool that will generate a windrose for the location nearest you and give you an idea of maybe how to locate the building based on that. Now, if you get into a situation where you're out in wide open space and you're trying to offer some protection for your buildings, and there really is nothing available, take a look and see if you've got some fencing or some trees that might help you in that regard. Windbreaks, when you have a grove of trees similar to what this top diagram shows, you can get wind protection, or it will modify the wind currents to about 10 to 20 times the tree height downwind. We can usually count on about 10 times the tree height. So if those trees are 30 feet high, it will influence the air currents downwind about 300 feet. And we can manage that a little better as well if we're dealing with snow issues. A solid fence is going to tend to pile snow, whereas a porous fence will tend to level out the snow. So if that's an issue around where your housing for your birds are, this is one of those ways that you can modify the environment for them. When we talk about natural ventilation, some of the basic things to consider here, and this applies whether it's in a chicken house or whether it's in your own home. Warm air rises and the cooler air tends to settle to the floor. And in order to provide a chimney effect, like you saw in that earlier diagram on summer ventilation, on how we're trying to move the air, get the hot air out of the building, it typically takes about a minimum of a 412 roof pitch in order to make that chimney effect actually move the air on out. And we're below, we're counting on it warming up and moving on out through the peak of the roof, and that's what's called the chimney effect. Warm air, another basic factor in natural ventilation, is warm air holds more moisture than cold air. And the water holding capacity typically doubles for every 18-degree temperature increase that you give to the air. And so if we look at this diagram on the at the bottom, you'll notice that for any unit of air, and that could be a cubic foot of air, it could be a room size full of air, but if it's 0 degrees, 0 degree air and 80% relative humidity, you notice it's pretty well loaded with water. If that could be a molecule of air. If you move it to the middle diagram, you'll notice that that same unit of air, when we warm it up, it expands the air. The temperature might go to 60 degrees, but it will drop the relative humidity of that air to 7%. And by doing that, it allows that molecule or unit of air to pick up more moisture. And this is the air that we can then dispose of excess moisture to the outside. So we've raised it to 60 degrees. We now have it back at 80% relative humidity, and we would exhaust that excess moisture outside the building. And so modifying or watching how much moisture is produced in the building will help determine whether this natural ventilation will work. Air circulation and air exchange helps prevent stale air buildup in the room, in the building. And what we're trying to do is get rid of that excess moisture. When we have manure from poultry, we're typically going to have some ammonia odors as well. Also, carbon dioxide levels tend to go up. This table that you see is for a commercial size poultry house, and you'll just see a kind of comparison of the different gases. Carbon dioxide is one where above 30% it's lethal. Where we like to see it is below 1%. Ammonia is one of those that we try to keep in below 400 or 40 parts per million. When you go above 500 parts per million, it becomes lethal. Oxygen levels, we want above 16%, and they will become lethal if it's closed up enough that there's not enough oxygen in the building. This is usually a bigger issue with large poultry buildings than it would be with a small poultry house. Another basic tenet of natural ventilation is that the ventilation needs in the summer are different than they are in the winter. In the summertime, what we're trying to do is get fresh air into the building and stale air out. So we may be moving quite a large volume of air through the building in order to make that happen, particularly if there's a lot of heat. In the wintertime, we're usually closing the building up in order to retain heat in the building, and then what we're trying to do is provide just enough air exchange that we can provide some respiration air for the birds, and also warm that air up a little bit so that they're not getting a cold draft on them, because we need to keep them healthy. And one way we can modify that is where we put the insulation and how much insulation we put in. It will help moderate the temperature swings that we have in the building. So if you want to get really technical about this for a commercial building, what we'd look at is how many cubic feet per minute of airflow that we would have through the building. And there's a general rule of thumb we use for that it's 0.1 CFM per pound of body weight of birds in the building for each 1 degree of outside air. So if, for example, it's 60 degrees outside, we need 0.6 CFM per pound body weight inside. And you can just multiply the math based on how many birds you have and what they weigh to determine how much air you need to move in the building. Now, in a naturally ventilated small building, one way to do that is watch the cobwebs. What we would typically look for if there are cobwebs, or if you've got run a really clean building and you don't have any cobwebs, just take a piece of thread and hold it between your fingers and dangle it down and watch to see that it has a little bit of movement to it. You're looking for some direction on the air and the fact that it actually moves it just a little bit, just kind of gently in the breeze. Another way to do this is light an incense stick or end of a smoky rope, or a rope that will produce smoke, and watch where the smoke drifts to. If it kind of sits there and doesn't have a definite direction to it, you really don't have very good ventilation in the building. What you're looking for is a definite movement of air toward the outlets that you provided in the building. I mentioned earlier the size of the house is based on the number of birds that you're going to put in it. So it just depends on what size birds you're going to have as to the space requirements. And again, these are the minimum space requirements that we would have. You could double these numbers and you won't hurt anything by doing that. But it comes down to a question of expense on the building that you're going to construct, and how we can build these things a little too large to where they could be a problem in the wintertime. We're relying a bit on the body heat of the birds to help heat the building, and if you make the volume of the building too big, too much floor space, you may have to provide some supplemental heat to offset that. Poultry house design, usually what we're trying to do is put the windows on the south side of the chicken coop, if this is something that or the hen house. The hen house would have, you wouldn't be able to get into, but the animals can. In a chicken coop, you could be in there as well. And what we're trying to do is provide both light and warmth. We can get some solar radiation through those windows in the wintertime that will help warm the building up. One of the things that tends to happen is the birds will like to sit on the windowsills if you make it easy for them. So it's always a good idea to put some slanted windowsills. This will discourage roosting on the windowsills and provide better, more maximum light exposure coming into the building. Those windows could also serve as vents. If they're on the south side, you may be able to, if these are windows that can be opened, they may serve as a ventilation source, particularly in the summertime in the south. We would take advantage of that and push air through the building and discharge it out through the peak of the roof. And so we're trying to provide ventilation there. If you notice that there's any dampness in the building, or you notice that your feet are sticking to the litter on the ground, or you notice an ammonia odor, that usually indicates that you aren't putting enough air through the building. It needs a little more ventilation. We try not to allow putting vents that open directly over the bird perch areas. When you put the roosts in there for the birds to set on, we don't want to, particularly in the wintertime, don't want to bring that cold air right on top of the birds, because that could chill them, create some health problems for them. But you can make that work by angling air inlets upward so that it shoots the air toward the ceiling. Then it will allow it to mix with that warm air that's up near the top and bring it down more toward the floor, and it will be warmer and drier air as it reaches the animal level. This is an example. This is a graphic that's courtesy of Purina Mills, where they just show a schematic here of different types, or a hen house for 6 birds, and how you might make one cost effective. There are probably some things that I would do different on this building. One of the things, it has some translucent corrugated roofing, which would be an issue in the summertime in my part of the state, because that would get extremely hot. We would need to provide some sort of a radiation barrier up there to prevent a lot of heat buildup in the building in the summertime. Another factor would be bringing air into this in the wintertime. You notice it's a pretty confined space, and trying to provide a perch area for the birds, we may be putting some air right on top of them. cold winter air. So depending on how you orient this building, you can change what happens to it. You may think about just facing it one way in the summertime and another way in the wintertime. It's not something that, if it's small enough to move around that way, that may be a simple way to provide some ventilation for the building. And you'll notice that there are some nest boxes here on the one side of the building that that could be a window instead, and you can locate the nest boxes on one of the sides of the building if you want. There are several ways that this could be set up. Notice that the waters and the feeders are outside in this case, and that actually is a helpful thing from a moisture point of view. If the birds are dropping water on the ground as they drink, it can get the litter wet, and that's going to be a cleaning issue for you. You need to keep that litter dry in the building. So there are literally hundreds of configurations of these small poultry houses that you will find if you just do a search on the internet. And some of them are good designs, some of them maybe not so good or need a little rethinking. I mentioned litter management. This is one of the ways that we can deal with moisture issues in the building. We want a deep absorbent litter that's clean and mold free. We want it dry but not dusty, and typically about a 3-inch depth is where we would start. Pine shavings, rice hulls, chopped straw, shredded newspaper, peanut shells, and ground corn cobs are all good types of litter that we could use for the bedding on the floor. Hardwood shavings, things from oak and hickory and ash, usually are not a good shaving material because they can produce molds when they get wet. And cedar shavings, some folks may have access to those. Those are generally not good. You'd think of cedar providing a nice odor in the building, that more pleasant odor, but when they get wet, they will really enhance the ammonia odors as well. And so try to avoid both hardwood and cedar shavings if you're going to provide bedding, or when you provide bedding in the building. That litter needs to be stirred occasionally to keep it from packing down. Where it gets wet, we need to dry that out to help reduce any odors, and this may either involve keeping the waters outdoors on a small hen house, or moving on a larger building, making sure that we clean up after the birds occasionally, scoop up the cake material that's underneath of the watering areas and move that out of the building. Under the roosting area, again, that's another spot that will tend to accumulate some moisture, and so as the birds urinate and defecate there on the ground, and so we want to make sure that we have a way to clean that out. Let me back up one screen here a second and show you that this is the clean out door for the roosting area in this particular building. And that's a way that you can get rid of that excess moisture source periodically through the year. The insulation side of things, what we're doing is moderating temperature here, and we're trying to either reduce the heat loss in the wintertime or the heat gain in the summertime that's going to come through the walls and the ceiling of the building. When you keep the building warmer, or the walls warmer, it will prevent some condensation. If you think about a glass of iced tea or ice water, when you put the ice cubes inside, it tends to create condensation on the outside of the glass. And so what we're trying to do is avoid condensation. If you think of the inside of that glass, that's really the outdoor temperature in the wintertime, and we're trying to prevent condensation on the inside by having lack of insulation there. And so by insulating, we can keep the inside temperature warmer, and therefore we prevent a condensation problem from occurring and creating moisture issues. And it also will reduce any supplemental heat requirements that might be needed in the building. Now, when you think about insulation, Uh, the way that you can compare different types of insulation is through R value. R value is just a measure of a material's ability to resist the flow of heat. So the higher the R value that you have, the less heat flow you're going to get through it, the better the insulating material will be. If you've ever bought vinyl siding for your house, you will find that the people selling that may quote you a pretty high R value for the material that you're putting on the house, because what they are doing is quoting you an installed basis, not a material basis. You always want to compare the materials, because what they're counting on is that you're going to have some other things, some basic construction in the wall on an installed basis that they're counting on to add to the insulation value. I'll show you that in just a minute. But if you're trying to figure out what's the most cost-effective one, then knowing what the R value per inch is will help you compute the lowest cost insulation for the application that you're going to do. And here's an example of that R value for a wall section. So in this case, we have some blanket type insulation. This could be a fiberglass batt that is rated as an R11. And really the whole wall, when you start adding the other materials together, this is an example of a typical residential construction wall. We usually wouldn't put 3/8 gypsum board on the inside of a poultry house, but we may use plywood instead and paint it. But we need some protection on that, and so you get a little bit of R value for the interior surface, you get a little bit of R value for the air moving over the outside surface. You get some for each of the building materials that come through, and each of these are just added up for the R value based on the thickness. And so the overall installed basis of this R11 insulation becomes an R13.45. And so, you know, make sure that you're comparing oranges to oranges and apples to apples when you're buying insulation. I'm often asked, how much insulation do we need in the building? Do we insulate it like we would like we do a house? You want to provide a minimum of about an R9 to an R13. If you're limited on where you can put insulation, at the very least, you've got to put insulation in the ceiling. That's going to do you a lot of good. It helps a lot in temperature control in the building. And make sure if you have the opportunity to insulate the walls, do that, because it will also minimize the amount of heat gain you get in the summertime, and it definitely reduces moisture accumulation or condensation on the inside walls in the wintertime. One of the issues that we have with any kind of insulation we put in is, how do we protect it from birds, whether it's the birds in the building or whether it's other birds that might want to, wildlife of some sort, or rodents, mice and rats and that type of thing. So we need to cover any exposed insulation that we have if it's a product that's not going to be a deterrent to these animals. And what I found is that there are very few insulation materials out there that you can put up that are not going to be either chewed on or pecked at by something. We need to provide a way to seal structural gaps. Mice, for example, can fit through anything that's a 1/4 inch space or larger. So if you have gaps around the construction of your building, make sure that you seal those up so that those rodents can't get in there. And once they get in the wall, you'll see something like this picture here to the right, where they literally will chew that insulation, tear it up, and make it useless for its intended purpose. We can limit how many rodents we get around these buildings by doing a good job of sanitation outside the chicken housing, and that involves cutting down, keeping the weeds and tall grass trimmed close, and that way it minimizes the chance that they will want to move in. Same thing applies with some of the insects and snakes and things that you might have, depending on what part of the country you're in. We can also reduce the amount of problems we have from these by storing feed in any sealed containers or keeping them separate outside the building in another area that we don't create problems for the building by putting the feed there. If we are going to store it there, have it in some sort of a container that makes it difficult for any critters to get into it. Just to show you an example, I mentioned that R9 and R13 for insulation values. If you compare that to what we would typically use in a home, you'll see that it varies all across the country. These are color coded. These are the newest Department of Energy recommendations, and it's based on the construction of the homes. So, for example, in my area of the country, we would be looking at attic insulation in a house as an R49, where the floor insulation would be an R25. And we don't need that much usually in a poultry house that's naturally ventilated, but the more you put in, the more it makes it manageable to work with. It just drives the cost of building the building up. Here's an example of some of the different types of insulation. The fiberglass bat insulation is one of those that's commonly used. It's fairly inexpensive and gives you a fairly decent R value for the money. It is one that has to be protected, and particularly from moisture. When it absorbs moisture, on any of these that have, if you fill the air pockets in this insulation up with water, it defeats the whole purpose of the insulation. So if the building has some leaky plumbing and you get the fiberglass wet at the bottom, it will wick up a couple of feet up the wall, and it will need to be replaced because it's no longer serving its purpose. Some of the others that we are seeing might be blown cellulose. It has a pretty good insulation value as well. And we can also, and these are all based on an R value per inch. So one that you definitely want to avoid in a poultry house is the expanded polystyrene. It's commonly called beadboard. It looks like that white material that coffee cups are made out of. And when you break it in your hands, it breaks out into little beads. It's got a decent R value per inch, but the problem with it is it also absorbs moisture really well. It's a great sponge, and birds and mice both love it because they will chew it and tear it up in short order. So extruded polystyrene is a better choice. It gives you a better R value. It's more expensive, but it also it's a pretty good. It's very resistant to moisture, so it tends to do well in situations in houses like this. The birds don't pick at it too much, and the mice don't like it too much either. But it's something that would probably need to be protected if you've got heat lamps in the building, because this stuff is just like the beadboard is prone, when it catches on fire, it burns hot and it's really smoky, and the fumes it gives off are pretty nasty. If you look down the lower right corner here, the polyisocyanurate or foil face foam is a fairly inexpensive board to put on. It has that foil can serve as a vapor barrier. I'll talk about that in just a minute, and it will it does a good job, but it tends to shrink down a little over time, so it does lose some of its insulation value. It also mice tend to like it a little bit too. They will chew on that stuff. When we think of a vapor barrier, you kind of think of 100% control of moisture. It's probably more accurately described as a vapor retarder in that it slows it down. What we're trying to prevent is that, as I mentioned earlier, that wet insulation, which will cause it to lose its effectiveness. And when it dries out, it usually does not regain its original insulation value. And in some cases, it may never dry out. Fiberglass insulation is one of those that just, once it gets wet, it really doesn't want to dry out. And so it needs to be taken out. The vapor barrier also protects the structural framing from wood rot issues. And when you're shopping for a vapor barrier, what you're looking for is something that has a perm rating of 1 or less. If you look at some of these materials, like open cell spray foam, it has a perm rating of, I'm trying to remember, it's 30 or 40, somewhere in that range. It's designed to let moisture go through it, and this makes when we're dealing with where do you put the vapor barrier. This is a real challenge in my area of the country, because in the southern parts of the country, the extreme south, we typically put that vapor barrier on the outside of the house and to prevent moisture issues from moving in. In the northern climates, we'd put that on the warm in winter side, meaning that we would have that inside, and that way the moisture can't move out through the wall. Here in Missouri, we actually have it both ways. We can have moisture issues moving both ways through the building because we're kind of in a transitional latitude for climate. And so it's a real challenge to figure out how do you put that insulation in so that and protect it so that moisture doesn't damage it, because we can get moisture moving from both directions. And this can happen literally within the same week. This week is a perfect example. We start out the week with high temperatures in the 70s, and we'll be looking at 20 degrees by tomorrow night. So real challenge to figure that out. But the type of insulation determines the need for the vapor barrier. If you're using something like fiberglass, like you see in this photo here on the upper left, a 4 or 6 mil polyethylene plastic over top of that will do a good job of protecting that insulation from getting wet. The spray foam insulation, like you see on the right, is a fairly expensive way to go, and probably not something most people are going to do for a small hen house or chicken coop. But it is, there are two versions. There's a closed cell and an open cell. And if I were picking one to do in a poultry house, I would probably use a closed cell, even though it's more expensive, because it can serve as a vapor barrier just with the foam. The open cell does not serve as a vapor barrier. The bottom one here, where it's a blown-in cellulose, it also needs a vapor barrier because it is prone to picking up some moisture. It does have additives in it that prevent termites from working on it. And also it's fire retardant, but it doesn't prevent it from getting wet. With that, I just kind of summarize here, the natural ventilation, it's a low-cost option for small housing. We do need some insulation and moisture control, but that's going to be dictated by the climate where you live. And you can find out more about that by contacting your extension office in the county where you live, because they will have information specific to your area of the country. And just managing the poultry, making sure that you do good sanitation practices go a long way to making the ventilation system work well. If we keep the moisture under control, we don't have to, and keep everything dry, it makes it very easy on the birds. It makes it a lot easier to deal with any issues that come up. And with that, I'll look and see if there's any questions, but I can move on to a couple. In the time I have left here, move on to some online resources that are available to people for planning before you start spending money on these things.
We haven't had any specific questions right now. Desiree had a question about humidity, reducing humidity. I don't know what her specific question was, whether or not you addressed it.
Okay.
So if Desiree, if you have it. Oh, here she is. New Hampshire has the same challenges climate-wise as Missouri. How can we deal with that?
Okay, where you have issues with wide temperature swings in any given week, and you're it may be hot one day and raining the next. I assume that's what you're dealing with in New Hampshire. that's it may be of value to not put a vapor barrier, but have a material that will withstand having moisture move through it. So open cell foam is an example of something that would work for that. It's a spray foam, or using something like an rigid insulation and extruded polystyrene. This is typically comes as a blue board, a yellow board, or a pink board at your big box store or home improvement center. And those are resistant to moisture. They're actually designed for in-ground use if you need them to. If you're trying to protect the water lines in cold weather, 2 inches of foam over top of a water line, it's a good way to protect that in really cold temperatures too. So to answer your question specifically, it kind of depends on the building and what you have dollar-wise to spend on it.
She just added a comment that she has all 4 seasons in one day.
I can totally relate to that. We can see the same thing here. So what I'm showing on the screen right now are several resources. I'm going to bump out of this slideshow and show you an example of some of those. The Ag Site Assessment Tool is something we developed here in Missouri, but it's useful anywhere in the country. And I'll show you how you can get the windrows for your location to tell you where your breezes, you may already know this, just standing outside and seeing where your breezes come from. And then this bottom link that shows to the backyard chickens, I'll show you a number of other resources that are available. But I'm not sure what the plan is, Jackie, for we'll put this online as a recording, I assume, and so
Yes.
My contact information is here. I'm going to switch out of this right now and go over to the Ag Site Assessment Tool. This is what, when you go to agsite.missouri, spelled out, .edu, it will pull up this screen. You'll notice it defaults to a different website, but we tried to keep it simple in how to enter that. And what you will do is enter a location. Just type your physical location, your 911 address into this box here. So my address here would be 800 South Marshall Street, Marshfield, Missouri. And I would just type that right into this box and then click on Open Tool. And what I've done for the sake of speed on this is I've already done that. So we'll switch over here and hang on a second. When I do that, I will pop up it will allow you to, it'll pull up an aerial photo of the location where you're at, and then you can zoom in or out on this to get whatever scope of area that you're interested in. You'll come over here to the Draw Outline tool, and in this case, my office is located right here. I just drew an outline around this field to the west of me, and it shows about a 14-acre field. And then from that, you can click on Generate Report, and it will tell you, it will bring up a report about all of your property. And so you can go down, let me see, let me go back here a second. Yeah, I went one too far. This is a report it will bring up. And so you can scroll down and you'll find out a lot of resources about that property. You can find out about the soils, any endangered species that you have. The climate that you're going to typically see through the year, what your normal temperatures are going to be, your high, mean, and low temperatures, and the amount of precipitation. And down here at the bottom will be a windrows, which tells you where your wind comes from in any given year. And you can click on that and it will change based on the month of the year that you pick. So you'll see we are pretty consistently about the same through the year. We can, if I uncheck some of these, that might help. Let's try that. Yeah, and it will, it does change around depending on the year or depending on the month, and the color will indicate the wind speed and how fast it's coming, which direction it's coming from. And then it will also show a map of that property at the bottom. When you click on some of the other things that are in there, for example, if we were to click on this soils map, it will, let me see if I can bring that one up. I can get rid of that menu. Yeah, it will drop a It will tell you all about the soils that that property has and what kind of plants you can grow on it, what you can use it for, whether it's limited or not limited. Where this database is coming from is your soil survey for your county. And so all of this has been digitized and put in here for you. If you're wanting to know about building roads to your property, to where you're building your chicken coop, it will tell you what you're going to run into as far as construction of that, or if you have a larger operation and you're trying to figure out, I think I want to maybe put in a sewage lagoon or something like that, it will tell you about building those, or building commercial buildings. If you're going to build a foundation under this house, are you going to have to, what kind of footings you're going to have to put in there? All of this is really useful information in terms of planning your farm, not just the poultry operation, but the whole farm. And that was just kind of a quick overview of that site. Let me take you to the other one, the backyard chicken page. If you will type in, if you go to extension.missouri.edu/Webster and put /backyard chickens, it will bring up a lot of the resources available that we put together for our chicken workshop a number of years ago. But I've updated this through the years, and so there's a lot of good resources here from different states, land-grant universities around the country that have some really good information related to backyard chicken production and some of the biosecurity issues that go with that, if you're going to, so that you minimize disease outbreaks and prevent problems from neighbors as well. So with that,
there was one question.
Yes.
Do you recommend monitoring the temperature and humidity with a wireless thermometer in the hen house throughout the year?
Yes, that's actually a good idea. What you're shooting for in the hen house is somewhere between a 30 and 60% relative humidity. In a naturally ventilated building, you're going to have certain periods of the year that temperature is going to go, or the humidity probably will go higher than 60, and it may go lower than that. Usually in the wintertime is when it goes down. In the summertime is when it goes up in my part of the country. These temperature humidity gauges, thermometer, hygrometer, can be purchased at a number of locations. You can find those if you have a local Walmart supercenter. You can find them in where they keep the thermometers. I would recommend going with the digital versions as opposed to the dial type versions, because the digital ones tend to be more accurate. And this is something that you'd want to do in your house as well. And they're typically available for $15 or less.
Somebody had a question. When my birds are roosting, the humidity goes to 80%. How do I fix that?
Okay, if you're noticing a high, if the humidity's up, but you're also noticing an ammonia odor that's coming with that, then that indicates that you need to move a little bit more air through the building and provide some better ventilation. So, okay, no odor associated with it. Where the birds are roosting, 80%, when I said 30 to 60%, that's typically what we're shooting for in commercial buildings. Naturally ventilated buildings, you're going to have a little wider fluctuation from that. So I wouldn't get real excited if it goes to 80%. Just recognize that it's kind of like people. These birds may be more prone to a few respiratory issues when you get the humidity level that high. The other really important thing is, as long as you keep things dry, that humidity really isn't going to bother you too much. As long as you're providing if the litter is dry, it will tend to keep things. That humidity isn't going to have a big effect on that, and the birds will stay healthy. So, 80%, when we get up to that range, we can, if we have moisture present, it will start trying to grow mold, and we want to avoid that. Okay. Will keeping all doors and windows, wait a minute, open during the day help? Depends on the time of year. If this is the summertime, absolutely. Yeah, the more air you can move through the building in the summertime, the better. Particularly, depends on where you are, climate-wise. In the wintertime, I would try in New Hampshire. I suspect that do you have pretty dry, is it pretty moist air? Are you close to any water bodies, or do you get a lot of breezes off of so dry and freezing, so and no water? All right, so that's actually a helpful thing, because we can keep the humidity. If it's dry and freezing, the humidity generally is going to be fairly low, but that humidity gauge will help you monitor that, and keeping the doors and windows open, as long as they're not drafty in the building. You know, if you're bringing air in high and taking it out, you can even take it out high. What I would probably use is some tilt-out doors at different locations, both high and low on the building. We used to raise chickens on the farm I grew up on, and that was one of the ways we managed that. We had about 400 birds in our chicken house, and we actually built the building in such a way that we could adjust vents both high and low on the walls, so that we could monitor or move air at different heights through the building. So if we needed to, we could bring the air in high and move it out low, even though it really wasn't designed to go that way. And it all depends on what your prevailing breezes are as to whether you're pushing air through it, because the inlets are what decides where that air goes. It's not the outlets.
If she's getting 80% humidity under the roosts, could that be a diet thing, where she's getting a lot of moisture in the fecal material because of whatever she's feeding? And could it be that she doesn't have bedding under the roosts to help absorb some of that humidity?
Right. Typically, there's not much bedding that's put underneath of the roofs, and that would be one way that you might be able to absorb it and then move it on out. You know, if there's a lot of moisture in what is the moisture of bird manure? It's around 77% water, I think.
Something like that, yeah.
Yeah. So if there's no way to absorb that, yeah, that could be contributing to that moisture issue. And pine shavings and chopped straw. Okay. Let's see here.
With 13 birds.
13 birds. Yeah, you're not producing a lot. They're not producing a lot there, but over time, yeah, it could build up. So it just depends on how often you go between clean out, I guess, is what I'm thinking.
Mm-hmm. Yeah, that will. I don't know. I find chopped straw not a very good absorbent.
Yeah, I don't either. Pine shavings are really one of the best ones. And I see she says going to deep litter in the wintertime.
That's going to have a lot of moisture.
It will. Yeah, you tend to hold more moisture the deeper the litter that you go, because it's going to sink on in. Let's see, if we raise the roof for a bigger gap, will that help? It will move more air. Okay, and usually, you know, what's going to happen when you move more air in the wintertime, you're going to bring the temperature down in the building. So you've got to make a decision. Are we going to, that's when I'd start watching the cobwebs or the smoke movement to see if I could I want a definite air movement in the building, but I don't want to be creating any drafts. And one of the ways that you can help reduce drafts too is by putting some window screen on the outside of your vents. As something smaller than quarter-inch hardware cloth will keep quarter-inch hardware cloth will keep out birds and that type of thing, but it also allows a lot of air to move through it. And window screening or a couple of layers of that, or even blocking off part of the vent in the wintertime, can help with that. Okay. 20 to 40 degrees in the wintertime. If the birds are dry, that's a little chilly, but they could probably 20 is a little low on the low side, wouldn't you say, Jackie?
A little bit, but as long as they're dry, the only thing was they'll eat more food.
Yes, yeah. And if you've got the groceries for them, they're going to need it.
Ron asks, might the increase in humidity be due to the decrease in temperature at night?
It could be. We see that happen here in Missouri, particularly in the summertime. Our temperature during the daytime might be 90 degrees, and the humidity will be about 50%. Nighttime, the temperature drops back to 70 degrees, and humidity goes to 95 to 100%. And when we have that type of situation, it's really challenging. That's where you've got to do a good job of keeping the moisture down in the building, because they're going to be dealing with heat anyway. And so we need enough air movement through there that we can keep the birds cool at night, but recognize that you're dragging a lot of humid air into the building that's going to have to be taken out the next day.
Right. Our time is up. In fact, we're a little past time. Thank you very much, Bob. You did a great job. For those of you that are still hanging around, the next webinar is in January 9th. We will be discussing poultry integrated pest management for flies, birds, and rodents. I hope you will join us then for that webinar. We don't have one figured out yet for February, but in March we are looking at environmental enrichment for small and backyard flocks. So some issues. If you have any questions, any suggestions for webinars, please email me. I can get this in right. And we'll see if we can get that up as a topic. So thank you for joining us, and hopefully we'll see you here again.